Welcome my friends! In this video, I'll be showing you how to graph cosecant and secant. Let's start with cosecant. Cosecant is the reciprocal of sine, so here I have the graph of y equals sine of x in a dotted line. We will use this to help us graph cosecant. We can always just take the reciprocal of any value that's on the graph of sine to find the value on cosecant. For example, at negative 3 pi over 2, we have a point of 1 on the graph of sine. The reciprocal of 1 is just 1, so we will also have that exact same point on the graph of cosecant. The same is true at negative pi over 2. At negative pi over 2, the graph of y equals sine of x has a value of negative 1. Cosecant is 1 divided by sine, so 1 divided by negative 1 is still negative 1. This will be the case at any time that sine is equal to 1 or negative 1. Sine will share a value with cosecant at those values, so also at pi over 2 and at 3 pi over 2. Next, let's think about the point 0, 0, which is on the graph of sine. Cosecant is the reciprocal of sine, or 1 divided by sine. If sine is equal to 0, then cosecant would be 1 divided by 0. That's going to be a problem, because we can't divide by 0 in mathematics. So therefore, when sine is equal to 0, cosecant is going to be undefined. We represent that by a dotted line. So at x equals 0, we have a dotted line. This will also be the case at any of the other places where sine is equal to 0. So at pi, at 2 pi, at negative 2 pi, or any multiple of pi. At each of these points, sine is equal to 0, and cosecant is 1 over sine, or 1 over 0, which is undefined in mathematics. We are indicating each of the undefined points on cosecant with a dotted line. The dotted lines are what we call vertical asymptotes. These are points that the graph will approach but never reach. Let me show you the graph of cosecant, and then I'll start to explain what's going on. Cosecant is the graph in the solid line, so over here, down here, over here, and not the dotted line of sine. I've only graphed sine for convenience, to help us see what's going on. As I've already mentioned, anytime that sine is equal to 1 or negative 1, we will have an equivalent point on cosecant, at negative 3 pi over 2, negative pi over 2, pi over 2, 3 pi over 2, etc. Anytime that sine is undefined, we will have a dotted line on the graph of cosecant, which the graph will approach but never reach. For example, at x is equal to 0, cosecant would be undefined. As we get closer and closer to x equals 0, the graph will approach positive infinity. Think about why that might be the case. If you have sine of a very, very small angle, such as 0.001, sine is going to be a very small value because sine is the y-coordinate on the unit circle. So if we have sine of something very small, then the y-coordinate would also be very small on the unit circle. If you take 1 and you divide by something very, very small, you're going to get something very, very large, which is why we approach positive infinity. In some of the other cases, such as when we are very close to 0, but very slightly negative, then sine of that value would be something very, very small and negative. So if you take 1 and divide by something very, very small and negative, you're going to get something very, very negative, approaching negative infinity. Let's talk about a few properties of this graph. The domain of the graph, which is the possible x values that you can plug into the function, is any real number except for multiples of pi. The way that we write that is that the domain is x is not equal to k times pi, where k is an integer. Every multiple of pi is where we had a vertical asymptote, a value that we couldn't plug into the function. These are the places where sine was equal to 0. The range of the function is anywhere from negative infinity all the way up to negative 1, as well as from 1 to positive infinity. In other words, we can get anything except for the values between negative 1 and 1. We can go anywhere down to negative infinity, as can be seen on the lower portions down here, and anything up to positive infinity, as can be seen in the upper portions up here. But we cannot get anything between negative 1 and 1. So therefore, this is our range. The period of this function is the same as the period of sine, which is just 2 pi. This function repeats itself every 2 pi radians. In order to graph cosecant, I typically graph sine first, and then graph cosecant on top of it. If we graph sine in a dotted line, anytime that we have a maximum on sine or a minimum on sine, we will have a shared point on cosecant. Anytime that sine is equal to 0, we will have a vertical asymptote on cosecant. Alright, let's take a look at the graph of secant. Secant is the reciprocal of cosine, so I've graphed cosine in a dotted line. Since secant is 1 divided by cosine, anytime that cosine is equal to 1 or negative 1, we will just get the exact same value on secant. 1 divided by 1 is 1, and 1 divided by negative 1 is negative 1. For example, at negative 2 pi, we have the point 1 on the graph of cosine. This will also be a point on secant, because secant is 1 over cosine, and 1 over 1 is just 1. The same is true at negative pi. We're at negative 1, so 1 over negative 1 is just negative 1. That's also true at 0, where we have 0, 1, and then at pi, where we have negative 1, and back at 2 pi, where we have 1. Just like with cosecant, we will have vertical asymptotes at any time where our cosine is equal to 0, which is at negative 3 pi over 2, negative pi over 2, pi over 2, and 3 pi over 2. These are points that the graph will approach but never reach. Here is the graph of y equals secant of x. Remember that the graph is only the solid line and not the dotted line. We only drew the dotted line for cosine for convenience. Just like how I typically graph sine before graphing cosecant, I typically graph cosine before graphing secant. Anytime that cosine has a maximum or a minimum, we will also share a point with secant. Anytime that cosine is equal to 0, we have a vertical asymptote. The domain of y equals secant of x is not equal to pi over 2 plus k times pi, where k is an integer. This is just a fancy way of saying that anytime that we have something pi over 2, we can't plug in a value into secant. So for example, at pi over 2, or 3 pi over 2, or 5 pi over 2, or negative pi over 2, or in general, pi over 2 plus k times pi, where k is an integer, that will be a value we cannot plug into our secant function. As far as the range, it's the exact same range that we had for cosecant. We can get anything from negative infinity all the way up to negative 1, or from 1 all the way up to positive infinity. Just like with cosecant and sine and cosine, the period is 2 pi. So this function repeats itself every 2 pi radians. Alright my friends, that finishes this video introducing the graphs of secant and cosecant. In the next video, we will practice graphing transformations of these functions.